Okay, the last step is to fill in the calculations tab, and this is where the magic happens, and it is also where your skills at reading a pump performance curve are going to come in very handy. This is what makes the energy audit that we do unique to the actual pump being used. And we're going to start by switching over to the calculations tab. The information above has already been calculated and filled in for the SPCS loads. It already knows based on our percentages from the previous pages, and so it's plugging in pump, GPM, TDH, efficiency. It's calculating the horsepower, kilowatts, how much is used throughout the cycle, and what the yearly operating costs are. And it plugs in all the information for everything that we have supplied. If we have left something at a 0, let me go show you what that looks like real quick. So if we are not going to do, say, the low bather mode, we would put that at 0%, the normal filter mode at 100%. And then when we go to the calculations page, you will notice that the low bather load has no time, no values, no calculations in there. So you can see as you change the percentages on the site data page, the values will change for the SPCS calculations. So what we're most concerned with now is entering the data for the conventional control system. This, when you get it, will already be sort of evenly spaced from your design point to your maximum flow, and it will also be evenly spaced for your percentage from design to maximum. This is going to be pretty close, and it would be applicable to most pump performance curves where the design point is at the best efficiency point and it goes downhill from there. A lot of times, however, you're going to find that you've got a pump where the best efficiency point is a little bit higher flow than the design point, and we can go back to the pump performance curve and we can gather information from the curve and all the data that's supplied by the manufacturer, and we can make this an even more accurate model. So in our case, let's take a quick look and we see where we're at here. We're going to take a quick look at the performance curve. We're going to look at the additional data that was provided by the pump manufacturer. And what I'm going to do is I'm going to jot these values down on a separate piece of paper so when I go back I can just enter them. So what we're most interested here under various performance data is what is the best efficiency point flow at the rated diameter. It's 1062 GPM, it's 6577. And the best efficiency for this pump is 84.98. We also want to look at the 120% rated flow at the rated diameter, and we're going to jot those values down too. And then we're going to go back to the calculations page now, and we are going to see where they fall. And so the first one, 65.77 right here. So we're going to change this value to 1062. We're going to change, now we're going to leave that value alone. It's close enough. We're going to change the efficiency at that point to 84.98. So now what we do is we need to sort of split the difference between these values, and that's about 84.8. Sorry, 0.8, not 0.9. And this flow probably still good at 1035, pretty close to in the middle there. Okay, the next point we had was 1200 GPM at 59 feet, so there's 60 feet. And you see, we were pretty close. Well, we're going to change that to make it even more accurate. So 1200 GPM, 60 feet. The efficiency at that point, however, was 83.5%. Okay, now what we need to do now is we can go back to the performance curve. It's a little challenging to do, but you can try to find your flow rates and heads and try to pick out the efficiencies, or you can do what we normally do and We'll take the 1345 down to 1200. We will come up with an even gapping for the flow rates and an even gapping for the efficiencies. We have found that that is insanely accurate. So I've already calculated what these are, so I can enter them quickly for you. So we're going to do these, and there you can see they're not changing by an awful lot. And then we're going to jump over to the efficiencies, and we've done the same thing with the efficiencies. Excuse me. Okay, and then we have to come down from 1200 down to 1062. We've got a few spaces to fill in here, and they do change a little bit. And 8. And we come in, we catch the efficiencies here. Okay, so now we've done all of our calculation fill-in blanks. We can take a look and see this unit looks like it saves about 46% of the annual energy cost. The conventional totals give you kilowatts used during the typical backwash cycle, what it looks like per year, and what the yearly operating costs are based on the kilowatt hours and the cost per kilowatt hour. So in the next video, we're going to look at those special situations on how to adjust this if the customer comes back and says, yes, this is beautiful, except I know that my energy cost does not exceed this amount. That'll be the next one.